So that leads now to the next, again, these kind of all build upon one another, is hypothesis testing. So again, to figure out whether you have something that is statistically significant or not, again, if you think about any kind of test that you do, whether it's statistical or otherwise, you always have something to compare it to. So that's why you always start with a null hypothesis. The null hypothesis means there's no difference, there's no relationship, there's nothing here, nada, nothing going on, okay? And that's your comparison. So that's what you always want to start with in your hypothesis testing is nothing here, okay? And then you have your alternative hypothesis. The alternative is what you actually think is going to happen, okay? But you have to start with your null so that you have something to compare. So the alternative, yes, there is a statistically significant difference or a statistically significant relationship, okay? And so then what you're going to do is you're either going to reject or you're going to fail to reject your null hypothesis. So if there is a significant difference or a significant relationship, then you reject the null. If there's not a significant difference, you're simply failing to reject the null. A lot of people make the mistake of saying, I've proven that there is a difference, or I've proven that there's not a difference. You're not proving anything. Go back to what you've understood about probability, okay? You're just simply saying, could the difference between these two groups have been due to chance? And you can say, you can reject your null, implying that there is a difference, but you're not going to be able to prove that that difference exists. So to do a hypothesis, there's actually a procedure that you go through for this to work. So you always want to start by setting your null hypothesis. You set your null and then your research or your alternative hypothesis. And then you want to select your statistic. Depending on the type of test that you do, you may have a t statistic. You may have a z-score. You may have an f statistic. You may have an r value. All of those are the outputs, are the products of the statistical test that you're doing, okay? And again, you want to set that up in advance. You don't want to be making this up as you go along, okay? So you say, if my F statistic is greater than X, and that you can get from a table in your book, or you can get it from the statistical program that you're using, such as like Excel or SPSS. And so then you set your decision rule. So if it's, let's say, if it's an F statistic, if the F statistic is greater than 9.7, I'm going to reject the null hypothesis. Then you compute your statistic, okay? And then based on that, you draw your conclusions and you figure out what's going on in your data based on that hypothesis testing. But you never want to do it in reverse order. You never want to do your statistics first and then work backwards into your hypothesis. That's actually breaking some fundamental rules of quantitative